All right, so today we're going to look at solving radical equations. All right, so these are the steps for solving our radical equations. So you should probably want to start writing these down. They are similar to what we've been doing, but some of them are slightly different because it does have a radical to start. So our first step is to make it so one radical is isolated on one side of the equation. Okay, and kind of what I highlighted there is what you could write if you want to shorten it down. Sometimes you may have two radicals, okay, within the equation. So if that's the case, you're just going to always isolate one radical at a time. So get one radical by itself and move the other one to the other side. Your second step is then we want to undo the radical. So today we're working strictly with square roots, but as we move on, we'll be working with cube roots or fourth roots. So you're going to undo that radical by taking whatever power you need to. So if we're undoing a square root, we'd square both sides. If we're undoing a cube root, we'd cube both sides. If we're undoing a fourth power, we'd take the fourth power of both sides. And so that would eliminate the radical on that one side. You then want to solve. Depending on the problem, you may still have a radical in there. Okay, so you may have to repeat steps 1 and 2. And then this is where you have to check your solutions. There are things called extraneous solutions, and extraneous solutions are extra answers that you can get algebraically. So the reason you have to check is because for these radical equations, you get what's called extraneous solutions. First 5 letters, it's extra. Extraneous solutions are extra solutions you get. When solving algebraically, that are not true solutions. So when you go back to check them, they don't check. They're not really a solution. All right, so here's our checkpoint 3. Again, our steps are above, but we're going to be solving the square root of x plus 3 plus 3 outside of that equals x. All right, so again, our first step is we want to isolate one of those radicals. So we only have one radical here, so I want to get it so that the only thing on that left side is the square root. So this plus 3, I'm going to have to get rid of, and I'm going to do that by subtracting 3. So I would still have the radical, and underneath that radical, I have x plus 3, and then on the right side, I'd have x minus 3. Our second step says we want to raise both sides to the nth power that we need. So we're taking the square root, we're going to raise everything to the second power to undo that. So I'm raising the left side to the second power, and then I have to raise the entire right side to the second power. So notice I'm putting the right side in parentheses and then squaring it from there. So from there, the left side, the square and the square root cancel, we're left with just x plus 3. And then I have x minus 3 quantity squared on the right side. So there's two ways we could do this, okay? One way, Remember, x minus 3 quantity squared is really x minus 3 times x minus 3. And then you can FOIL that right side. So we get x squared minus 3x minus 3x plus 9. So that would give us x squared minus 6x plus 9. Remember, the other way we can do that, that binomial squared, that was one of our shortcuts we had. And we're going to be doing this so much, this binomial squared, you might want to remember the shortcut. Remember, the shortcut is square the first term. Okay, we did that. First term was x, we squared it. We double the product. So our product would be negative 3x. X times negative 3 is negative 3x. And then I double that, so that'd be negative 6x. And then you square the last term. So our second term, our last term, or second term is negative 3. Negative 3 squared is positive 9. So that is just a shortcut you can use to remember the binomial squared. If you prefer to FOIL it out, go for it. There's nothing wrong with it. But we're going to be doing this so much that you may want, if you can remember that shortcut, that would be a good thing to do. All right, so we don't have any more radicals, so we don't have to worry about that. And then it says solve this resulting equation. So this resulting equation that we currently have has x squares and x's. So it's a quadratic equation, so we have to get one side equal to what? 0. So I'm going to keep everything on the right side because my x squared is already positive on the right. And I'm going to subtract this x from the negative 6x. I'm going to subtract 3. And that would give us x squared minus 7x plus 6 equals 0 now. Which we can solve that by SAM factoring. What multiplies to 6 and adds to negative 7. Logan, what do you think? All right, negative 6, negative 1. And then when we set those factors equal to 0, we get x equals positive 6, x equals positive 1. Now again, these radical equations can create that extraneous solution. So we have to check these. Remember on Friday I said if you want to check, you can, you don't have to. But when you have these radical equations, you got to check. Especially when you get two answers. All right, so when I go to check this, if I plug 6 in first, I would have 6, square root of 6 plus 3, plus 3 on the outside, equals 6. 6 plus 3 is 9, square root of 9 is 3, and then 3 plus 3 is 6. So I get 6 equals 6. So that one worked. I know for sure 6 is in solution. When I go and plug in x equals 1, let's see what happens. 1 plus 3, square root of 1 plus 3, plus 3 equals 1. And so I get the square root of 4, and the square root of 4 is 2. 2 plus 3 is 5. Does 5 equal 1? It does not. So that one is not a solution. Therefore, the only thing that should go in our solution set is the 6. Okay, the 1 is not really a solution. And if you want to cross it off here, you can do that also. All right. All right, next problem. I still have the steps above here, but the problem is square root of x plus 5 minus the square root of x minus 3 equals 2. All right, so now we have two radicals in our equation to start. And again, step one says we're going to isolate just one radical on the side. So I'm just going to keep the radical that is the x plus 5, and I'm going to move this whole radical over to the other side. So the way I'm going to do that is, since it's already a minus square root of x minus 3, I'm going to just add square root of x minus 3 to both sides. So you're just doing the opposite of the operation to that whole radical. What's inside that radical does not change. So on the left, we would still have the square root of x plus 5. On the right, we'd have 2 plus. Actually, I like to put the radical first. It doesn't matter, but I'm going to write the radical first. It does not matter, though. Square root of x minus 3 plus 2 on the outside of that. All right, so now we're going to undo the square root by squaring both sides. So I'm going to square the left side. I'm going to put the right side in parentheses and square that. All right, so the square and the square root cancel. So that gives me just x plus 5. Now, again, the binomial squared. Either you're writing it twice in foiling or you're going to follow the shortcut. I'll write it twice here for now. And so as I go to FOIL this, I'd have square root of x minus 3 times the square root of x minus 3. What would that give us? I have the same square root times itself. What's another way I could write this? Square root of x minus 3 what? Squared. So what essentially is happening to the square and the square root? They're canceling out. So you're left, when you do that f part of FOIL, just x minus 3. As I do the O part of FOIL, 2 times the square root of x minus 3. That would be plus 2 root x minus 3. As I do the I part of FOIL, 2 times square root of x minus 3, so another plus 2 root x minus 3s. And then 2 times 2 is positive 4. So that gives us, combining any like terms, there's no other x's, so I'd have just x. 4 minus 3 is positive 1. And then these are the same radicals, so they're like radicals. So I have 2 root x minus 3 plus 2 root x minus 3. So that means I'm adding those coefficients and leaving it as root x minus 3. So it gives me 4 root x minus 3. That is a plus sign. But what do you notice about this problem? What do we still have in it? Still a radical, right? So that's where in our steps, where it says we may have to repeat steps 1 and 2 again, this is a case where we're going to have to repeat steps 1 and 2. So the first thing we're going to do is isolate that radical again. So I'm going to subtract x and subtract 1. And so on one side, I'd have 4 root x minus 3. And on the other side, x minus x cancels out. 5 minus 1 is 4. Now, is that square root isolated yet? Is that the only thing on the left side, or is there something else outside of that? There's the 4, right? So we got to get rid of that 4 still. It's 4 times, so we undo multiplication with division. So now that the 4's cancel, now yes, that radical is isolated. And we would have 4 divided by 4 is 1. And so now again, that was like step 1. Now step 2 is we're raising both sides to the second power now. So the square and the square root cancel. And we would get 1 squared. Remember, squaring a number just means 1 times 1. So we get 1 here. And then all we have to do is add 3. And our x would be by itself. So we're getting one answer here, which would be x equals 4. Again, we want to check our solutions, make sure that they are accurate and correct, not extraneous. So our check. Again, our original problem was the square root of x plus 5, so I'm going to put 4 in here, 4 plus 5, minus square root of 4 minus 3 equals 2. 4 plus 5 is 9, square root of 9, square root of 9 is 3. 4 minus 3 is 1, square root of 1 is 1. 3 minus 1 is 2. So yes, we get 2 equals 2. So therefore, we get one answer for our solution set, which is 4. All right, you're working on page 185. Numbers 11 to 19, odd, and then number 23.